Hello everyone. Thank you for coming to this session today, where we will be talking about building generative AI apps on Google Cloud and LangChain. Really excited to dive into this. We're going to cover a few different topics here. So we're going to discuss what LangChain is. We're going to talk about Cloud Run. We're going to hear a customer story from L'Oreal. And then, most excitingly of all, we're going to see some demos. So with that, let's jump right into it. Let's chat about LangChain first. So a little bit of background. My name is Harrison Chase. I'm the CEO and co-founder of LangChain. And LangChain is a way to build large language model applications. So specifically, it's a way to connect large language models to external sources of data and computation. And it's a way to create applications that are context-aware and that can reason. And so what exactly this means is it's combining a language model with your data, and it's able to answer questions that it might not have been trained on. And there's a few reasons to use LangChain. So first, it does all of this connection, there's a few concrete things that make it powerful. There's these connectors themselves. So there's all this different data from all these different sources, and once you have it, you need to load it into a different store to be able to access it more easily with language models. And so we have an interoperable and interchangeable set of these building blocks. And these building blocks don't just apply to data either, or only. They apply to things like language models. So there are over 60 different language models that you can choose from, and today we'll see a demo using one of them, Gemini, that got some really powerful updates yesterday. Another thing that we've really emphasized is the customizability and control that you can have with applications that you build with LangChain. So particularly in the past 6 months, we've focused a lot on low-level and customizable runtimes, like LangChain expression language and LangGraph, that make it really easy for people to customize their applications to the business logic that it requires. And so LangChain itself is completely open source. We have over 2,000 different contributors, which I think speaks to the volume and number of these large components. And we've recently introduced a way to deploy LangChain even easier. So with LangServe, you can add a LangChain application to Fast API with just one line of code. And so it exposes 6 or 7 different endpoints that allow for a variety of ways of interacting with the language model. So you can interact with it in a single request. You can interact with it in a batch request. You can also do streaming. And so streaming is an important UX consideration for LLM-powered applications. And with LangServe, you can automatically add that into Fast API. And so you've now got this LangChain application that you've built with LangChain. You've hooked it up to Fast API with LangServe. But how do you deploy it? So this is a great quote from one of our founding engineers, Nuno, on deploying LangServe on Cloud Run. And so Cloud Run is the easiest and fastest way to get your LangChain app running in production. And I think that naturally begs the question, what is Cloud Run, and how can I use it? And for that, I'm going to hand it over to Staren.
Thanks, Harrison. So, what is Cloud Run? Let's talk about it. I am Staren Giannini. I'm a product manager at Google Cloud. Cloud Run is Google Cloud's serverless runtime. It enables you to run applications fast and securely in a fully managed environment. Actually, Cloud Functions itself is built on Cloud Run. So, what is the fundamental value of Cloud Run? Let's take a look. It is both an experience and a runtime coupled with a very unique pricing. Let's talk about its experience. Well, Cloud Run is simple. It demands as little as possible. Cloud Run is automated. Cloud Run takes care of a lot of things for you. Cloud Run has top satisfaction and usability scores. And finally, it makes developers more productive, notably by using idiomatic development patterns, but also just by allowing them to deploy very fast. Second, Cloud Run's value proposition is also a very unique runtime. This runtime is capable. It is capable of running any code, any container in a serverless environment. It is an on-demand runtime. You have no pre-provisioning to do, no cluster to create in advance. You literally ask Cloud Run to run your code, run your container on demand. This runtime is what we say hyper-elastic. So Cloud Run includes a fast automatic autoscaler that notably scales down to 0 if you need to. And obviously, it's a serverless environment. There is no infrastructure management, no VM to create, no cluster to upgrade, no infrastructure. And this very valuable experience and runtime is priced in a very interesting way. It is literally an on-demand pricing. You pay only when your code or your container is running with 100 millisecond granularity. For testing purposes, there is a perpetual monthly free tier. And if you have any baseline of traffic, you really should consider purchasing a committed use discount to lower your costs. So Cloud Run's pricing is pay-per-use, no flat fee. If you don't use it, you just don't pay for it. So let's see how Cloud Run can help building GenAI applications. First, Cloud Run services. So that use case is what we are talking about today. It's about serving and orchestrating your GenAI application. In that case, it's a very similar pattern as web serving. There is a request-response flow between the GenAI app and its users, and this Cloud Run service runs LangChain to orchestrate the retrieval augmented generation, also known as RAG, to prepare prompts, to call the inference endpoint, and to format the response back to the end user. So here, the Google Cloud components you would be using are an application load balancer with Cloud CDN for some caching, a Cloud Run service, calling a Vertex AI inference endpoint, and calling Cloud SQL for a vector database. So Cloud Run services is one of the two resources of Cloud Run. Let's take a look at the benefits of Cloud Run services. Well, out of the box, you get an HTTPS endpoint. Each Cloud Run service is automatically scaled, and that scaling can be very fast. When you deploy to that service, it creates a new revision, and you have a revision history. You can even traffic split between two revisions of that service. Cloud Run services are flexible, allowing you to run popular GenAI application frameworks, and in any language. So LangChain, for example, is available in Python and JavaScript and some other community languages. Cloud Run has built-in integrations to give you all you need to easily set up your GenAI app. For example, Vertex AI integration, Cloud SQL integration, custom domains. Harrison talked about it, but Cloud Run supports out-of-the-box response streaming. So you can use things like HTTP chunk transfer encoding, HTTP2, or even WebSockets to stream your LLM's response back to the end user as it is being generated. That is really important to lower the latency of your LLM app. Right? You want the response to stream as soon as possible to the end user. And finally, Cloud Run is enterprise ready. Cloud Run has a direct connectivity to your VPC networks and have very fine-grained security and networking controls. So these were Cloud Run services for serving and orchestrating your GenAI app. This is the main component of your GenAI app. But there are other things you need to do in that app. And for that, you're going to use Cloud Run jobs. The first use case is data ingestion. So here, your goal is to prepare and process external data and to load this data into a vector database to be used for RAG. So the Google Cloud components you would be using, for example, are cloud storage and imaging. Every time a file goes into cloud storage, it would trigger a Cloud Run job using pub/sub. This Cloud Run job would call the Vertex AI embedding API, gets the embeds, and stores them in a vector database like Cloud SQL or AlloDB using the pgvector plugin. Another use case for your GenAI app is to evaluate the quality of your service. You really want to be sure that what your service serves to end users really doesn't degrade over time and actually hopefully improves over time. So you can use a Cloud Run job to evaluate the quality of the responses on a regular basis. For example, you would have a set of golden evaluation prompts that you would run on your service every day, and you would make sure that the quality is there. So for that, it is super straightforward. You use something called Cloud Scheduler, which is literally cron in the cloud, to every day, for example, trigger a Cloud Run job, and this Cloud Run job would test and evaluate a set of prompts on your Cloud Run service, which is serving your LLM app. So let's talk a bit about the benefits of Cloud Run jobs. Cloud Run jobs are on-demand execution of any code, any container. Like Cloud Run services, they scale to 0 when you don't need them, and when you execute them, you can automatically and rapidly scale to as many tasks as you want, up to 10,000 tasks. So each of those tasks could potentially evaluate one prompt. And each of those tasks, in the case of data ingestion, if the data is very long to process, can take up to 40 hours to execute. This Cloud Run job can be executed manually using command line, user interface, but more importantly, on a schedule or triggered via PubSub or events. And you get a nice execution history, including logs and task completion success. So I want to invite Thomas from L'Oréal, who's going to show you how they've built an app using Cloud Run and LangChain.
Good morning, everyone. Thank you. The mic is working. Before starting, I just have one quick question for you. Do you know L'Oréal? Yes? No? Maybe? The answer is yes. Because what? Because we are the first worldwide cosmetic company. We have 40 brands around the world selling 7 billion products last year. One product for each of us in this planet last year. So you know L'Oréal. And also, we are the 4th worldwide advertiser. So you could imagine the number of money we spend on Google Ads each year. And also, we have 90,000 employees. Magic. So we have 90,000 employees around the world, and you can imagine that with these numbers, we have a huge creativity inside our walls. That's why we needed, as soon as we could, to secure an access to GenAI for everyone inside the company. That's why we started developing last year, in September, thanks to LangChain and Cloud Run, a solution to do text-to-text and text. And the global opening was done only in 3 months. So we started mid-September, we delivered to the entire company worldwide in mid-December last year. And you can imagine, as a marketing company, the adoption is huge. But it was only the beginning of the journey, because we decided to use this use case as a flagship to deliver what we call the GenAI as a service. What is GenAI as a service? It's a set of declarative APIs that brings flexibility to IT teams that are willing to do GenAI apps, such as L'Oréal GPT, but for their own businesses around the world, with bringing the choice of the LLM. They could use Gemini, but also some competitors' LLMs. It's robust and validated by security guys, by architecture guys, but also by legal guys, meaning that each and every use cases that will start at L'Oréal using GenAI don't have to take care about how do I connect to Gemini, what's the billing methods of it, and so on. And also, this is, thanks to LangChain and Cloud Run, very fast and very easy to deploy. And we don't care about, will my app absorb the load because Cloud Run is absorbing the load easily. Last but not least, by avoiding silos and reinventing the wheel every time, and you can imagine a big company like us with more than 5,000 IT teams, IT employees, people are willing to create and reinvent the wheel each time we do a new project. And by creating those GenAI services, finally we save time and we save also money. But you will tell me, what are doing those APIs? Finally, we are doing what's the most popular stuff we can do with GenAI today. We are doing prompt, so just a completion, with the full flexibility in terms of LLM you could choose. We are also doing chat with multi-turn, with session memory, long-term memory, and very soon we will add multimodality, so the ability to upload a picture, upload a video, to be able to ask questions on them. We are also delivering APIs to generate images. So let's imagine at L'Oréal we have a lot of marketing teams that are using Midjourney. Now we are bringing them into L'Oréal GPT to be able to ideate, create content, and so on. And we are bringing some new features such as in-painting, out-painting, upscaling, background removal, and so on. And last but not least, we are also providing APIs to do RAG. But more than a long speech, would you like to see a live demonstration? Yes. So I just have to remember my password. That's it. So we will start with L'Oréal GPT, and you see that people can select the models. So it's open to everyone through the company. They have a wide choice of models. I won't open the drop-down list because I don't want to show some competitors' models. But you can see that it has been announced yesterday morning during the keynote. It's already live in production to all our employees. We have Gemini Pro 1.5, 1 million token for everyone. And you have to know that this is real live demo. This is not a Figma mockup, because we believe into our developers. We believe into LangChain capabilities, but also into Cloud Run. And so I will do one simple example. I will take a PDF on my computer, which is my hotel voucher. And so I upload it into GCS. I do OCRization, and then I will put that into my context. So it takes some time probably to wake up, but if it fails, because it could, I have a backup. So you see, it has been uploaded, and it has been read, and I will have a first message. So the document has been uploaded, and I can start to ask questions on it. So I ask to summarize the doc. So it will use the full document, sent to Gemini Pro 1.5, and then I will be able to ask questions on it, and I will have a good answer because we are leveraging Gemini 1.5. And finally, it tells me everything around my voucher, where I'm sleeping, how much night out of sleeping, and so on. And because we are doing a nice session, I will ask Gemini to write an email to Harrison, to Styron, but also Witzer, to bring them to an after party tonight. And I want him to propose me and to offer me 3 nice places to do the party. And so, Styron, which one do you prefer? The rooftop? Okay, let's go for tonight. This was one part of the session. Then another one. We are working, by creating knowledges, so RAG, into our app to bring to our employees ease of access into information. And so you can select some knowledges. And for example, I will use the operations knowledge. And I will be able to ask questions. So, am I able to wear diamond ring in plants? So I have some cookie issues probably, but it tells me that I'm not allowed to wear a diamond ring in plants, and is giving me its sources. And so you see, it takes the information from 4 PDFs, I can click on the PDF. I see the chunk which was uploaded into the vector DB. And I will also see the page number explaining me the truth. And I can click on it to visualize the PDF and to be sure that finally what the LLM told me is the truth or not. But you will say, why is this guy showing L'Oreal GPT while he was speaking about APIs? So I will show you some APIs. And so this is a simple notebook to show you that with the services we are developing for our IT teams, we are able very fast to leverage those APIs for our use cases. And so you see I'm connecting to my APIs there. I said that I leverage my business context. I put my access token, and then here we go. I create some definitions to simplify the ease of to read my stuff, but then I create a first configuration. So you see, I create a config which is called Google Next Simple, which is of type prompt. I choose my LLM, which is Text Gemini Pro, with the temperature, and I ask him to translate the text to English. And so I delete my conf if it was already existing, I post it, and then I put my payload, and I call my generation API with my payload to say, here is my payload, do this job with this model, and give me the answer. And you see, it says, hello to the Google Next audience from L'Oreal, because you're worth it. For those who know, this is the very famous advertise from L'Oreal. And I will do with a bigger payload. It's a French article where two good guys were speaking about what we do at L'Oreal. Antoine Castex, our data architect, and myself. So I've created it, and then I will show you that I'm leveraging the same prompt. I'm leveraging the same config, sorry, but I switched to Gemini 1.5, and I changed the template. I asked him to translate to English and to summarize into one sentence. You see, I patched my config, so it reuses everything, but changed only the stuff that I asked to change, and then it did the job. Let's start now to have a more complex demo. You will see that I will create a new configuration, but that time I change a little bit my template. It's a little bit more complex. I'm leveraging some of the famous args that I can find on LangChain, such as the max output tokens. And I will use the output parser, because I want my answer to be JSON and not just a string. And thanks to the cool features we have on LangChain, we can do it. I create my config, and then I leverage it. You see, it's created, and then we wait a few seconds, and it extracted the title, the date, what's the role of Antoine, and what's my role from the article. And last but not least, I will show you a more complex example, leveraging what we could do as prompt engineering thanks to our services, because we are doing few short examples, thanks again to LangChain. So we are putting some inputs and outputs, so what people can write, what we expect as an answer. I'm leveraging, again, Gemini 1.5, a max output token, a temperature, a template, and an output parser in JSON. So we are leveraging everything from LangChain to do something. And you will see, my payload is Eva Longoria brushing her hair, 8K, and so on. And it will tell me that I have a famous person in this prompt, I don't have nudity, and I have a reason explaining this stuff. And this stuff, this is what we are using in L'Oreal GPT when you want to generate an image. When you type your prompt, we call this configuration with the prompt of the user to be sure that our internal persons cannot generate famous persons or nudity. And so we are leveraging our prompt and configs, and you see that thanks to the APIs we are doing, people just have to care about their business requirements and not about architecture, security, and tech, because they are just leveraging APIs. Can we go back to the slides, please? Sorry. Thank you. And so, as I said, we are leveraging Cloud Run everywhere. We decided to cut Cloud Run by functions. And you will see that everything which is blue, it's already live at L'Oréal. And you see that when you have the LangChain logo, this is where we leverage LangChain. And you see that LangChain is leveraged everywhere. And we are actively working now with Harrison on the evaluation stuff. And we want to deploy as soon as we could Langsmith, because we have more and more users, more and more business case. We want to be able to evaluate the prompt we are doing, evaluate them against the models, and also evaluate RAG capabilities to be sure that when we deliver a new feature, the accuracy is better and not regressing. And last but not least, as we said, we are a great lover of LangChain. We are using them a lot. But as L'Oréal, we decided to contribute also to this community. And the first example is the system prompt in Gemini. Probably you all, if you are users of Gemini, in the chat mode, you probably noticed that the engineers forgot to have systems prompt. You only have human AI, human AI, human AI. So as we were using previous models from other competitors, we were used to have system prompts. And so what did we do? We, with Google, developed some code to mimic the fact that we are using system prompt with Gemini. It's passed into the first human message, and we did a pull request into LangChain. And the true story is that Harrison himself didn't know about L'Oréal before. He validated this pull request. And we did some others. And now, if you want to replicate, what we've done in 3 months, but in a faster way, I let the floor to Vitze that will show you how to leverage it as soon as you could. Thank you.
And yes, okay, good, thank you. Sometimes it's the little challenges, right? Okay, but it's going to go easier from now on because I'm going to build and deploy a LangChain app to Cloud Run. And this is what the app can do. You can ask it questions, like, can I mount a cloud storage bucket as a volume in Cloud Run? And this app will retrieve relevant release nodes from Cloud Run and prompt Gemini with it, right? So I'll come up with a response, like something like this. Yes, it's supported since January 19. Well, let's talk system architecture. So I'll take those release nodes, I'll store them in a vector database. And vector databases are great because they let me do similarity search, right? So I take the user query, and I do a search, and I get back relevant release nodes. And I'll serve this LangChain app on Cloud Run. I will use LangServe for it. So I'll use the LangChain CLI to scaffold the LangServe API. And finally, I'll use Cloud Run jobs to import all those release nodes from a data set that we have published in BigQuery. I'll index them, compute the embeddings, and insert the embeddings into the vector store. So let's create the infrastructure resources. Can we switch to the demo line? Hello? Maybe you can help me. This is going to be good. This is teamwork. Okay, so can we switch? Yes. Okay. Is this good now? Yeah? Okay, so I'm going to use a feature that's in private preview today. So you're actually going to be the first people outside of Google to see this. This is a Cloud Run web console, and there's a button, Manage Application here. And here's an input field. It says, describe your desired app architecture. So let's do that. A LangChain app with a vector database. So I'll come up with something. A Cloud Run service and a Cloud SQL database, right? That makes sense. Cloud SQL, every new instance, oh, this is better. Every new instance comes with pgvector by default, right? So that's a vector store. Hey, but I also need Gemini, so I'm going to ask can you connect the Cloud Run service to Gemini? I like that LLMs don't worry if I make typos. And it adds another service. Oh, that's not good. So let's try again. A Gen AI app. This is what you have to appreciate with LLMs, right? The creativity. There you go. Oh, this looks better. If I zoom out a bit. So there you are, Cloud Run Service, Cloud SQL database, and Gemini. Do you like this? It can be a bit louder. I mean, this is the United States, right? Yeah. Awesome. This is more like I'm in the Netherlands, right? Goed gedaan, jongen. Now get back to work. Okay. Dutch guy there in the audience. Okay, well, I tell you, I can take this deployment, and I can actually press deploy. So it's not just this canvas, right? Press deploy. Boom, it starts to create the resources. Huh? Yeah. Okay, so now we'll wait for a little bit for everything to be created. No kidding. I have a separate project, and everything is created already. Okay, so now we need to write some code, right? So let's hop to the terminal. I'll use the LangChain CLI to scaffold a new LangChain app for me. So I'll do LangChain app new, folder, next 2024, no extra packages. So now created a folder for me with a blank LangServe app. And I'm not going to use it because I don't want to have you folks wait on me download the entire internet. So I did this morning and I pre-installed all the dependencies. But just imagine that it's the same directory, okay? I'll open it in Visual Studio Code. There you go. There's a server.py here. And all this needs is my LangChain chain. So let's add that. Playground, yes. Okay, so let's add a chain. So I've put in all the work to manually pre-configure autocomplete snippets, so you don't have to watch me struggle and make typos. So there's a chain, right? So this doesn't really look like regular Python, right? There's all the bars here. So I made a little visual explanation of how this works. So any LangChain chain is a sequence of calls to LangChain components, right? So I start with this turning a query into the same query in a list of release notes by retrieving them from the vector store. And then I stuff that into a prompt template. And then I take the prompt that comes out of it, and I send it to the large language model. And finally, I parse a string out of it, and then you get the answer back. So let's do that. So there you go. So start with initializing the vector, store. I'll use pgvector for it. Oh, I'm missing some imports. Let's quickly add those. I promise you, when I'm usually programming, it doesn't go as fast as this. Wasn't that funny? Okay. So I initialize the connection string, and all those environment variables have already been injected for me by the app canvas, so I don't need to worry about setting that up. Okay, so next up is the retriever, right? So I can send a query to it, and I'll get a list of documents back. Retriever, there you go. So we'll take the list of documents, and then it will concatenate all of them to have one string, because that's what my next step needs, right? So the LangChain chain, the output of one component is the input of the next, right? So now my prompt template gets a query and the release notes, and it returns a prompt. Now, a prompt template, that's a string template, right? So here's my prompt. You're a Cloud Run expert. this might be me, answering questions. I use the retrieve release notes to answer questions, and if you're unsure of the answer, please say so. Here's the release notes, here's your question. What's your answer? And then finally, turn the prompt into a response from the LLM. So I'm initializing Gemini 1.0 Pro here, low temperature, because I like the stuff to be a bit predictable, low number of output tokens. And then finally, I'm chaining everything together, and I'll pass that to LangServe to wrap a REST API around it. I got a playground that I can use to demo. So let's see if that works locally. Drop into the Poetry shell and do Python app server. So while that's starting up, I'm already starting the deploy to Cloud Run. So taking a folder here, do gcloud run deploy. Source is going to be the local directory. Name of the service, service 1, because that's what I created. So let's kick that off, see if it started. OK, it runs locally, so that means my deployment is going to succeed. So that's good. OK, but hey, there's one more thing. We need to import those release notes, right, from the public data set in BigQuery to Cloud SQL using a Cloud Run job. So I'm going to add a new file here, indexer.py. And there we go. 3 steps. Retrieve all the Cloud Run release nodes. I got a list of rows. Initialize pgvector again. And then submit all those documents to the vector store. OK, BigQuery. Ooh, that's a lot of code. OK. It's not complicated, I promise. Select all the release nodes where the product name is Cloud Run. And then you have a list of rows. Run me. Nope. So initializing pgvector. Let me close this so you can see the whole thing. So this is a very similar way to instantiate the vector database. And then finally, I'll take the list of rows, turn them into, give them to the vector store, and add them. So I'm going to run this using Cloud Run jobs. And to save time, I've already done this before this session. So I'm going to show you how I configured it. So back to the, I'll switch to my demo project here. So services is you start a container image to serve web requests. Jobs is start a container image, run it from start to finish. Right? So that's that indexer.py thing that's going to run for me. So if I go to the job that I've already deployed and I edit it, then you can see I take the same container image as my web service was using, but I also added this indexer.py file in there. And I'll change the entry point using Python, execute my indexer.py. And if I look at the logs of this execution, I can see that it worked when I last did this, because it says number of release nodes, 197, and it's now done saving. So all my data is there. Let's see if my Cloud Run deployment has succeeded. And it's creating a revision. It's already building the container. So what this command did was it took my local directory source code, submitted it to Cloud Build, and that kicked off Docker Build, and pushed the container image to Artifact Registry, and now it's creating a new revision, and boom, it's live. So we can explore my app. So there we go. Does Cloud Run support volume mounts? Like my typing ability decreases a lot if people are watching at me, looking at me. Yes, Cloud Run supports volume mounts, including NFS, Cloud Storage, Cloud File Store, etc., and in-memory volumes. And what's nice about this playground, this LangServe playground, is that you can step down in all the steps that you just saw in the LangChain chain, right? So here's the whole sequence. This is the retriever, and there you can see all the documents that are retrieved from the release notes. And what's nice is that it actually combines several release notes to come to this answer, right? NFS file share, Cloud Storage release node, a whole bunch of file systems back when we launched the second generation runtime. So one other question. Can Cloud Run make me a sandwich? Thanks for not being creative, Gemini. The provided release notes do not mention anything about Cloud Run being able to make sandwiches. Yeah, so if we switch back to the slides now. Maybe Sarah, you want to come up and close out this session. So if you want to reproduce what I just did, you can scan the QR code. I'll show you how to scaffold the LangServe app real quick and deploy it to Cloud Run. Between the plans, people. Between the plans. Grab the microphone, yes.
Test, okay. You can actually do all of this at home by following the code lab. So in conclusion, we've seen that GenAI apps are context aware and rely on a language model to reason. Then we've seen that LangChain is a flexible toolkit for building GenAI apps with interchangeable data sources and building blocks. And finally, we've seen how Cloud Run is a perfect match to run your LangChain app for your GenAI app. Thank you for attending this session. Now you can go to Dev Keynote.